In this question, we're going to be looking at verifying some specific property of triangles. So we're actually given a specific triangle here, so we're not going to really generalize this concept, but work with something concrete. And we're given 3 points that define it. They're over here. Okay, and what I've done ahead of time, I've just put these points A, B, and C on the grid. So here they are. I have my A value as -1, 3. My B value is 5, 7. My C value is 4, -2. So that's step 1 done, and I've also connected all these points to form a triangle. Step 2 says to find the coordinates of the midpoints of AB and BC. So if you recall, the midpoint of 2 points, given 2 points, is going to be x1 plus x2 divided by 2, comma, and it's the same thing except instead of the x's, I'm going to put y. So it'll be y1 plus y2 divided by 2. So I have y1 here, y2 here. And this equals, in this case for AB, I get -1 plus 5 divided by 2, comma, 3 plus 7 divided by 2, close bracket, equals 2, comma 5, close bracket. And I'm going to do the same thing for BC. So BC in this case becomes, I have 5 plus 4. Again, if you want, just look at the values for B and C over here, divided by 2, comma, 7 minus 2 divided by 2. Simplified, I get 9 over 2, or 4.5, and 5 over 2, and 2.5. So these points, if I go to my graph, are going to be at 2, comma 5. So 2, comma 5 is roughly over here. Now I'm a bit off with my diagram, so I'll make it big so it covers the triangle, the side that is. And 4.5 and 2.5 is roughly here. There we go. So those are our midpoints. So this is equal to this, and this side is equal to this side. Step 3 says join the midpoints together to create the mid-segments of the triangle. So the mid-segment of a triangle is when you take 2 midpoints and you connect them with a straight line. Okay, so there is my mid-segment, 1. I mean, there are others, but we're just going to look at that one for now. And step 4, or part 4, asks us to verify that the mid-segment is parallel to one side of the triangle. So if you look at the diagram and consider the mid-segment we just drew, which is the only one right now, it's probably going to be parallel to AC. So how do I verify that? Well, let me find the slope of this guy here. Let me find the slope of this guy here. Find out what they're equal to. If they are the same number, we know that parallel lines have the same slope, and vice versa. So let's start off. I'm going to calculate the slope of AC. So slope of AC is given by, I'll just plug in the values. I'm going to skip the definition of the equation. I suggest maybe you look into your notes just to remind yourself what it is. Leaves me with -5 over 5, which is equal to -1. So that's the slope of AC. The slope of the mid-segment, so slope, let's call it MS for mid-segment, is going to be, well, I take the midpoints in this case. So I go 5 minus 5 over 2 over 2 minus 9 over 2. This gives me 2.5 positive on the top, -2.5 on the bottom, which is -1. Again, I would recommend you understand how I went from here to here. I'm not going to take the time to explain that. Try going over it yourself. See if you can understand how I did that. Anyways, this is good news. I have -1 here. I have -1 here. the slopes are parallel indeed. The lines are parallel indeed. So that's good news. The last part is I want to show that the mid-segment, this guy, oops, wrong one, this guy here is half the length of the parallel side. So how am I going to do that? Well, if something is half the length, if I were to find the length of, say, this side here, let me use a red, and determine that if I found the length of this side here and divide it by 2, I will get this guy, then I've proven my statement. So let's start on that idea. Let's find the length of both the mid-segment and the side AC and see what we get. So I'm going to have here the length, or you know what, we'll use D for distance. We've been using that lately, of AC is equal to, again, I'm not going to write out the formula at this point. You should know it by heart. But I want you to try to understand where these numbers are coming from. Okay, I'm not just choosing them at random. Okay, I'm not going to tell you the points I'm using because it's indicated by here. But please check the diagram to make sure that you understand where these points are coming from. This leaves me with negative 5 squared plus 5 squared, which is equal to the square root of 50, which is approximately 7.1. Moving on. If I want to now find the distance of the mid-segment, so distance of mid-segment, or length of it, same thing. I use my distance formula. Give me some more space here. And I'm going to go 5 over 2 minus 5 squared plus 9 over 2 minus 2 squared. This gives me the square root of negative 2.5 squared plus 2.5 again squared. And then if I do that, I end up with the square root of 12.5, which is equal to 3.53. And although it's not exact, it's quite close. If I were to actually round it to 1 decimal place, so for example, if I got rid of that 3, got rid of that 1, this side length here will be 7, this side length here will be 3.5. Lo and behold, 7 divided by 2 is 3.5. And this verifies that the length of my mid-segment is half the length of the parallel side to it.